Consider the set of values of z such that the distance of z from 2i is equal to the mod of z minus 2 plus 3i. Now we need to rewrite that slightly. So that's going to be z such that z minus 2i, so we can see that's the distance of z from 2i. And here we have to make this z minus and put the point in a bracket. So that's going to be 2 minus 3i. If we put that in a bracket, think about expanding it back out again. So it's the set of points z such that the distance of z from 2i is equal to the distance of z from 2, negative 3. So 2i is here, and 2, negative 3 is here. And so if we draw in the line segment between those, we want the midpoint. Now the midpoint is going to be at 1, and so 2i down to negative 3i, so that's going to be here at negative a half. So the midpoint there is at 1, negative 0.5, and of course we can always do the calculation for that. We have the point 0, 2, and we have the point 2, negative 3, and so the midpoint is the average of the x's and the average of the y's, and that will give me 1, negative 0.5. Then the gradient of this one, so if we go 2 across, we're going 5 down, so that's negative 5 over 2. So the gradient of this one has got to be 2/5. And that means if we go 5 across, we go 2 up. So 1, 2, 3, 4, 5. 1, 2. So what we want is a straight line that goes through those 2 points, like so. Now, in part B, we want the Cartesian equation. So, there's a couple of different ways we could do this, and the safest way is probably to go from here, or at least from here. We know mod z minus 2i is mod z take away 2 minus 3i, and then let z be equal to x plus iy in the usual way. Remember, a Cartesian equation is going to relate x and y. So that's x plus iy minus 2i is equal to the mod of z, which of course we're replacing with x plus iy, take away 2 minus 3i. So that one's going to give me x plus I, y minus 2, and over here I'm going to get x minus 2 plus I, y plus 3. We know how to work out the modulus. This is going to be x squared plus y minus 2 squared, all square rooted, is x minus 2 all squared plus y plus 3 all squared, all square rooted. And expanding out, so we've squared both sides basically, I've removed the square root, and then expanding out we get x squared plus y squared minus 4y plus 4 is x squared minus 4x plus 4 plus y squared plus 6y plus 9. So the x squareds will cancel out, the y squareds will cancel out, and the 4's here will cancel out. So negative 4y is negative 4x plus 6y plus 9. And so if we bring everything over to the right, that gives me 10y minus 4x plus 9 is equal to 0. Now an alternative is that we worked out that the gradient of our line was 2/5 and that it went through 1, negative 0.5. So we could just use y minus y1 is equal to m x minus x1. So y take away negative 0.5 is 2/5 of x take away 1. Bring the 5 up here. 5 into y plus 0.5 is equal to 2x minus 1. So 5y add 2.5 is equal to 2x minus 2. 5y is equal to 2x take away 4.5. Let's double that to get rid of the decimal. 10y is equal to 4x take 9. And then we could rearrange that however we want to rearrange it, and I'm just going to rearrange it so that it's the same as this.